So, let us have some introduction and the explanation on this particular topic. This is related to the practical chemistry. In that also we are confining to the one part, that is organic chemistry, practical organic chemistry. Actually, we have already completed a certain part, that characterization of the compound through the purification part and the estimation of the elements, that is detection of the elements and the estimation of the elements. Thereby we calculate the percentages, and then we go for the deciding the empirical formula, and then molecular weight deciding, and then the formula deciding. At that stage we have already completed. Now we are specifically observing the remaining part of this practical organic chemistry. In this chemistry, if a compound is given, that is a part we have identified, that is molecular formula up to that, then how to proceed the rest of the part to decide what compound is given, we are going to observe. One of the crucial part is checking their solubility. This you may call it as a solubility chart. Based on this solubility chart, we are going to have two questions. One is, if a compound is soluble in this one, then immediately guessing that what type of compound it may be. This is the one type. Another one is if two compounds of a mixture, specific mixture is given, how you are going to separate using the certain technique, specifically in the solvent extraction. Also this solubility comes. So, let us have some salient features of this particular solubility chart. Then let us go for the serial number. Then the solvent, different solvents I am describing. First you have to check with the ether, then the water, then with the dilute sodium bicarbonate, dilute sodium hydroxide, dilute HCl, directly concentrated you have to take here, concentrated H2SO4. Based on this solubility, we are going to decide the nature of the compound. Nature of the compound given, we are going to identify. The first class of the compounds will be, let the compound, if it is acidic, like for example, you can take an example also you can, that is a standard example. So, an example, if the compound is a basic compound, the basis will be with reference to the base, that is common compounds will go. For example, if this is the compound, this is a benzene with NH2, this NH2 is basic in nature, ammonia derivative it is. So, the nature will be basic. So, what will be the expected character means the basis will be soluble in the acid. This plus mark shows the solubility, and insoluble in both the two bases. There are two bases, two acids are given, but these two bases are important. Out of the acid, second acid is not that important, except in one or two cases. The sulfuric acid is not that prominent, because there is one reason. All organic compounds, inevitably they are soluble in the concentrated sulfuric acid, excepting in one or two cases. The observation should be very clear. All are soluble, I repeat once again, but with one or two exceptions. One is hydrocarbons like alkanes and the benzene, alkyl benzenes, not hydroxy benzenes or carboxylic acid benzene. So, the hydrocarbons means alkanes, not alkenes and alkynes again, saturated only. That is, alkanes are not soluble in the sulfuric acid, yet even at high temperature also. And benzene is not soluble. Benzene with alkylated benzene, that is arenes you can take, double benzenes, naphthalene, anthracene, or alkyl benzene, toluene, xylene, these compounds are insoluble. including ethers also soluble. Ethers will have a oxygen with lone pairs, a protonation, salt formation, therefore consequently they are soluble. So, all the compounds are soluble excepting the alkanes and the benzene, alkyl benzenes, that is all. So, therefore, this column you need not to check at all, because all organic compounds are soluble. But we do check specifically in the case of amines, salt formation is taking place. This is the first observation. With amines, if you take amine, add sulfuric acid drop by drop, not at a time more, drop by drop if you add. At one stage that hydrochloride salt is formed, which is a solid. Salt means a solid formation you can observe. So, this is one specific point with reference to the sulfuric acid and the amine. The others are not important. We can have also one more important point. All organic compounds so called are soluble in the ether and insoluble in the water. This is common to most of the compounds. Solubility in the, because all are organic compounds, this is a perfect organic solvent, diethyl ether we take. So, all organic compounds are commonly soluble in ether, insoluble in water. That is the nature of the organic compound. If it is organic compound, solubility in organic solvent ether, insolubility in the, that is inorganic solvent water. This should be the criteria for the organic compound in fact. But these are so specific with reference to the basicity, acidity. Two bases, out of the two bases also one is weak base, one is strong base. So, both it is because it is base itself. So, bases insolubility, solids soluble in the acids, then we can take it as a base it is. So, let us have a common code. B is I am giving a compound base means B, let us B type of compound. Now, serial number 2 is acids we take. In the acids we have two types, weak acids, strong acid. So, acid with weak and acid with strong, strong acid, weak acid. Okay. So, weak acid means phenol. Phenol will be the weak acid and carboxylic acid like benzene with COOH is the strong acid. Benzoic acid is the strong acid. S stands for the strong. How it will be their solubility? Acids are now soluble in the bases, but insoluble in the acids. Acids insoluble. Again we have some small complication here. Let us not discuss this one first. Let us discuss this benzoic acid. Because it is acidic, it is soluble in the bases, bicarbonate as well as the sodium hydroxide, and it is supposed to soluble both acids. But I said all compounds are soluble in the sulfuric acid because sulfuric acid is a very strong protonating agent. A proton will be attacked. Salt is formed, therefore it is salt. So, this solubility you need not to check, all will be the positive only, okay, except in one or two cases I will tell. So, this sulfuric acid again it is soluble. So, this specifically the sodium hydroxide and HCl. So, because it is a acid, acid is insoluble, base is soluble, these two, acid soluble, acid not, so acid will not be soluble in the acid, acid is soluble in the base because the salt formation, right. But phenol, how the phenol behaves. Now, coming to the ether, it is that is same, that is. So, ether it is soluble, water insoluble, right. So, phenol will be again one ether soluble, water insoluble. But coming to this specific observation, among the two bases, because it is weak acid, soluble in the strong base, but insoluble in the weak base. This is very, very important point in the case of the phenols. Phenols are acidic, but not soluble in the bases, so called bicarbonate. Bicarbonate is a weak base, that is a weak acid. Both are weak, therefore it is not soluble. Therefore, we will say the phenols are soluble in the sodium hydroxide, but insoluble. Both soluble means it is strong acid, benzoic acid. Soluble in base, but not the bicarbonate, so therefore it is the phenol. Here in the form of Salt also we have one point to note, importance of the salt formation means immediately you can say amine it is. Now coming to this two, all are soluble in the sulfuric acid, you need not to check, therefore this is plus. But because it is acid, it is insoluble in the HCl. So acids are insoluble in the acids, soluble in the bases, but unfortunately because it is weak acid, it is not soluble in the bicarbonate. That is very much specific. Then the fourth category, let us go to the, now the bases and acids are over. Then the neutral compounds we have to take. Before taking the neutral compounds, we have another class called the carbohydrates. Carbohydrates, let us designate with the C. Okay. So the carbohydrates example is glucose, C6H12. Structure is big, so I am giving the formula C6H12O6. This is glucose. Glucose has a number of hydroxy functions and one aldehyde function. So because of that more dominating OH functions, unfortunately it is reverse case with the all general compounds are behavior different, and it is reversed because it has so many OHs, it is soluble in the water, insoluble in the ether. But the test should be very perfect. The test tube should be anhydrous condition, and sulfate, that is ether, should be anhydrous. Then you take glucose, add small quantity of ether, insolubility comes. Ether insoluble is the only one compound that is this type of compounds. Even salts like sodium benzoate or aniline hydrochloride, even salts are insoluble in the ether, but the salts we don't have. So in general, a compound, organic compound, it is insoluble in the ether means immediately you can note this point, it may be carbohydrate. Because the glucose is soluble in water, so it is soluble in the water. These are all water solution, therefore you need not to do any test, simply you can go for the plus. Even if you are doing also, it is your ignorance it becomes, because it is all, these are all made up of with water. When it is soluble in the water, definitely they will be. However, concentrated sulfuric acid, I said all are soluble, but specifically a carbohydrate like glucose, when you add constant sulfuric acid, if the sulfuric acid is perfectly anhydrous, very concentrated, black carbon formation, all H2O will be detached, then what remains is carbon. That's called charring. Specifically, if you heat it, you will get carbon formation. This we call it as a charring. So carbon formation, that is the formula you can write C6H2O 6 times. All H2O you remove, what remains? Carbon. That is what carbohydrates, when you heat it with sulfuric acid, they get soluble, that is actually solubility. It becomes almost a test like sulfuric acid, add it and heat it, the carbon remains H2O detached from the system. So therefore the carbon formation charring is one test for the even carbohydrates in fact. So they can be considered. Now what will be the inference of the, that is a chart study of the carbohydrates means, carbohydrate, they are all soluble in all the compounds except in the ether. Ether insoluble, rest of the compound soluble. This is a perfect this one, so therefore it is soluble. Water soluble, ether insoluble. This reverse situation is the carbohydrate. Then the fifth type will be the neutral compound. Neutral compounds also again can be in two types. Neutral compounds, let us designate with N. There is a neutral compound with a higher molecular weight, high molecular weight, and a neutral compound with a low molecular weight. High molecular weight means you can take as a benzaldehyde, benzophenone and so on. A compound is all carbonyl compounds, esters come under the neutral. This is type. Low molecular weight means acetaldehyde or acetone. Carbonyl compounds or any organic compound with low molecular weight also you can take, like alcohol, methanol. all acids with low molecular weight, all low molecular weight also you can take it, not only neutral, but all low molecular weight also behaves like water solubility they chose. All low molecular weight are soluble in the water. When once they are soluble in the water, they are soluble in the rest of the other compounds also. Okay. Because they are low molecular weight organic, they are also soluble in the even ether also. See, all are soluble. Sulfuric acid anyhow soluble. So they have no partiality. Acids and bases all are soluble means neutral, isn't it? But the benzophenone type of compounds are really, they are not soluble in the water, soluble in the ether. So this non-solubility in the water, solubility in their ether soluble means they are soluble in the they are soluble in the ether, but they are insoluble in the acids and bases. This is their neutrality. Neutrality means not partial. Acids also, bases also, they are not soluble. Acids also not soluble, but sulfuric acid all are soluble, therefore this can be exempted. But acid and bases, if you see, acid insoluble, bases insoluble, that is neutrality. Acid soluble, bases soluble, that is neutrality. Being all soluble or being all not soluble is the neutrality. But in the neutral compounds we have a higher molecular weight like benzophenone. If you take benzophenone is insoluble in water, soluble in the ether. This insolubility it shows in all the acids and bases. An acetone, acetaldehyde, or acids like smaller acids like acetic acid, smaller alcohol, smaller amines. Aniline is showing so specification here, acids and bases demarcation. But if a methyl amine, if you take, they are soluble in the water, soluble in the ether, soluble in all the compounds. So all low molecular weight specifically which can show hydrogen bonding, they are not having any partiality, soluble in the ether, soluble in the water, hence soluble in all other compounds also. This type of compound generally we don't give in for the students to identify, but the compounds of the other varieties like aniline is a specific example for the base. Phenol is an acid but weak acid, benzoic acid strong acid, glucose carbohydrate or benzophenone. Taking these four compounds as a characteristic examples are the specific examples, we can have a number of separation techniques and all that also. So by studying the given compound solubility, one can come to a conclusion that whether it is basic or acidic, in the acids weak acid, strong acid, or a neutral compound with high molecular weight, low molecular weight, or the abnormal behavior, that is water soluble and ether insolubility specifically shows. These 2 points, water solubility and ether insolubility, reflect the generally carbohydrate or salts of organic compounds like even amino acids exist as wetter ions. They are also ether insoluble, water soluble, like glycine for example, glycine, alanine, these amino acids also they exist as wetter ions, cation anion structure. They are also salts, inner salts. They are also ether insoluble, water soluble, exception case it is. So water solubility, ether insolubility generally we don't get, but low molecular weight compounds also soluble in the water. So water soluble means either it may be carbohydrate or low molecular weight containing neutral or even all compounds also low molecular weight are soluble in the water. So these are the specifications and the solubility. Based on that we can guess for the structure. For example, it may be showing the basic property amine. Then we will go for the detection of that amines properties, a specific example, that is characteristics tests we have to do it, and then go for the specific the characteristic tests also. Then we have to prove that it is a amine function is there. Later what are the other functions in the present and all that molecular. Once the functional group is decided, we can go for the next examination of the further compound.